Okay, so what I'll go over with you guys is the ImageNet algorithm that I have on the CODIDO site. So just to quickly um, show you what it is, it's this one right here. So all this one does is it just takes in an image, runs it through the MobileNet V2 model, and then it outputs a prediction. So this is an example of an algorithm that's fairly short. So this will help get the important points across, and then hopefully that'll make everything else make more sense. So first thing that I want to go over through is just the Docker file. So as you may or may not know, the Docker file is basically kind of the blueprint or instructions for setting up your Docker container. And then this Docker container is what will be running your algorithm. So when you run this Docker container, you can think of it as just being a completely separate thing from your local machine. So that means we need to set up everything on this Docker container. So this includes stuff like downloading Python packages, downloading Linux packages, copying over your code, etc. So the first thing that is always present in this Docker file is this from line. And this is what's known as your base image. So what's a base image? Well, if your base image is just Ubuntu or some sort of operating system, then that means it'll just be a fresh operating system from the factory, meaning you have to manually install Python and other Linux packages and everything. And you do this by adding more commands to the Docker file. But if I put something like Python as my base image, then this means I don't need to install Python, as the Docker container will already have Python pre-installed. And this gets more important when you're doing some deep learning stuff and you don't want to manually install all the deep learning libraries and GPU support and GPU drivers, since that thing can get pretty messy. So what I have for this example is I'm using a TensorFlow base image. So this will make all the TensorFlow GPU stuff all set up already. So this is a huge head start, but there still may be things that I require. And that's why I have these extra run apt install commands. So these are just Linux commands. And then run basically makes it so that these commands are being run on the Docker container. So it doesn't get run on my local machine. And so how did I know that these kind of packages, these Linux packages are the ones that I needed? Well, I would first run my algorithm without these lines, realized it's giving me errors, and then after searching, I learned that these are the things that I needed to install on the Docker container. So that's that. And now this is an important thing, so I'll cover this too. But when I specify this TensorFlow base image, what operating system and what architecture is my Docker container being built for? So for this, there's a site called Docker Hub. So I already have that open here. And here you can basically find all the different base images that you can use for this, for the first line of your Docker file. So if I search up this, the TensorFlow one that I have, and then you can click on tags, and these are all the different versions that exist. So I can see that all of these TensorFlow Docker images, they're all built for, they're all built for Linux, and the architecture is AMD 64. So it's pretty much all of them here. So that means that when I compile my Docker container, it's going to be for Linux or AMD 64. And so the computer that I'm running on right now, it is Linux and AMD 64. So that means that after I do a Docker build and then I'm able to run this Docker container on this computer. And our CODIDO servers are also Linux AMD 64. So the problem arises when, what if your machine that you're developing on, what if it's Windows or if it's some sort of other processor or something else? Well, in that case, actually, you wouldn't be able to run this Docker container on your computer. So that's kind of why pretty much all machines that are used for development, they're kind of they're usually a form of Linux and AMD 64. But this is for TensorFlow. So if you guys are not doing deep learning algorithms, then you have alternatives because one of the main reasons to use one of these Docker images for TensorFlow or PyTorch or something is, as I mentioned, it'll set up all the headachy stuff like the GPU drivers and stuff for your Docker container. But if you just want to do something simpler, like just some regular math or non deep learning stuff, then you'll be fine just using a Python base image like I have here. Um, so if we search up Python on Docker Hub, we'll actually have a lot more options than the TensorFlow one. So um, yeah, just looking at this one, for example, we can see that they have way more operating system architecture support pretty much for every single computer. So regardless of what your machine is, you can basically run a Python Docker container on your computer. So if you type in something like what I have here, just from Python in the version 3.9.16, it'll automatically build for your operating system. And then you can test locally with no issue. And then when you're ready to submit to CODIDO, well, as as we recall, the CODIDO machines use our Linux computer, AMD 64. So if your machine is Windows or something that's not this, then after you finish testing locally, make sure everything works, then you'll just have to uh, build your Docker image again using the right operating system and processor. And this is all specified in the how-to guide. But yeah, I just wanted you guys to know that you can search up Docker base images on Docker Hub and see the OS compatibility and whatnot. So moving along in the Docker file, we also need a way to copy over our code files to the Docker container, since as we mentioned, the Docker container is going to be a separate entity that's kind of running on its own. So we need a copy, or I want to copy over all these files that I have in this directory to my Docker container so that my Docker container is able to run this code. So that's what this line does, this copy dot dot. So this is just the most general way to copy everything from my current directory to the current directory in the Docker container. That's what the dots mean. So current directory in in this file, it makes sense since our current directory is this project directory, but we don't exactly know where it's going to be copied over to in the Docker container because what exactly does current directory mean in the context of the Docker container? So we want to kind of remove this ambiguity, and hence we have this command right above it. And this is workdir /app. So this means that when I do the copy dot dot, it'll copy all my project files in this directory to the directory in the Docker container called /app. So inside the Docker container, we'll basically have like /app /ImageNet MobileNet v2 /app /inputs /app /outputs /app /app.py. All of these things are going to be under the app directory in the Docker container. So yeah, so now we know where exactly in the Docker container we're working in, and this allows us to, or this will have some further implications as we'll see. And so another point you may wonder is why am I separating out the copying of requirements.txt? Because when I'm doing copy dot dot, it's going to copy over everything in this project directory to the Docker container. So this is kind of redundant. Like, why do I have this, right? So that's correct. But the thing to keep in mind is that Docker files start running from the point that they got changed. So this is pretty important because, for example, if I change the base image, so let's say right now it's the TensorFlow one, let's say that I want to switch to the Python one. So let's say I switch it, then what does that mean? Well, it means that everything below it is going to be rerun. So it's going to first download this new Docker base image, and then it's going to run everything all over again. And this can obviously take a long time. Or if I just add like another run line, say I say run apt-get something else, then that means that everything below that is going to be rerun again as well. So it would make sense that you want to separate out all the things that don't change often and put it at the top, and put all the things that do change often at the bottom like I have here. So since we're already copying this requirements.txt file up here, it's not going to copy it when I do copy dot dot. So because now they're now separated, when our code file changes, then only the stuff below the copy dot dot would be run. Well, first it would obviously copy the new code files over, and then it would run whatever lines I have below here, which is basically nothing. And so this allows us to develop quickly. And so this concept can also be extended to the base image because, although the requirements.txt file may not change often, it's still going to occasionally change. And you don't want large core libraries like TensorFlow to be downloaded each time. So by using the TensorFlow base image, we don't need to specify TensorFlow in the requirements.txt as it's already going to be installed as part of the first line. So what do you have now? So now you have this efficient system where the top line installs TensorFlow in the GPU setup. And these are large things, but they're not going to change. So this line is not going to be rerun. And then it's followed by these extra Linux packages, which also can be large, but they're also not going to change. So this is not going to be rerun. Followed by the requirements.txt. It does change, but to a lesser extent. So even if it does rerun, it's okay. And then this is all followed by your working project directory. And this includes your code and whatever you have in your project directory, apart from the requirements. And so this stuff does change a lot. But rerunning this is fast since you're basically just copying code files for the most part. And you may have some large inputs or large machine learning models. Like for example, I have this ImageNet MobileNet v2 folder, and this is just basically just the model, the machine learning model that I'm using. But this is small, so even though I'm copying over this every single time, it's fine because it's not that big. But let's say that you did have some large inputs or large machine learning models, and you don't want to copy them over every single time. But keep in mind that the speed of copying between our local machine and the Docker container is actually fairly fast. So depending on how it is for you, you can always separate it out like I did for the requirements. So I could have something like copy ImageNet underscore MobileNet v2. And then that means that when I do the copy dot dot, it's not going to copy that over every single time. But yeah, I think for the most part, you can just leave the structure as is, since the requirements and the base image are going to be the biggest time-consuming steps in your Docker image or in your Docker file. So the next thing is entry point. So this is just where do we start the algorithm. So in this example, our script that we want to run is called app.py, but this could be anything. And then the CMD part allows us to add extra command line arguments. So if I just had this is no command line arguments. And then when you're doing local testing, you need to specify this command line argument. So you can just copy this over as is. And why we need this, when we go over the code, you'll see. And yeah, if your algorithm takes in extra command line arguments, then you can just specify that here in the same format that we have it here. So overall, there's not too many changes you need to make to the given Docker file template. This is all specified in the website as well. So at this point, you can build your Docker container and run it. But we generally want inputs, and we generally want to see the outputs from our algorithm as well. So this was recently added to the guide a few weeks back, but as mentioned in the guide, we now have these two extra folders called inputs and outputs. And these are things that you want to add to your project directory. And this is a mechanism for testing locally on your own computer. So yeah, there's the inputs folder, outputs folder. Outputs folder will just be empty, so there's nothing in here. And inputs is where you can put your input when you want to do testing. So for this example, I just have a single input, just a cat image. So inside of here, this can either be nothing. So sometimes your algorithm might not even need an input. For example, our AI art generator application on CODIDO, it doesn't take in an input, or it doesn't take in a file. Um, or inside of this folder, you can put a single file like I did here, or you could put a zip file if your algorithm requires multiple inputs. So now let's look at the actual algorithm code itself. So at the top, we've got some imports. And then here we can see that there's input and output command line arguments, but these are not used when testing locally. But they are here for when your algorithm is run online on the CODIDO platform. So when testing locally, you'll have these lines, but you can pretty much just ignore them. Because for testing locally, we already have, the inputs and outputs folders that we created here. And these are the things that we want to use. So we don't need any command line arguments for this. So if we look at line 19 and 20 over here, this is creating the actual folder paths. So again, remember how we said that in the Docker file, we marked the /app folder as our working directory when we performed our copy. So again, this means that this whole project directory is going to exist in this /app folder in our Docker container. So that means this inputs folder and outputs folder is accessible at /app/inputs in our Docker container and /app/outputs on our Docker container. And so that's what I have here. I specified that the input folder is /app/inputs and the output folder is /app/outputs. And then yeah, go ahead. Yes, you leave lines 12, 13, 14 as is. And then if you have extra command line arguments that you want, so for example, this ImageNet algorithm, it doesn't require any other um, command line arguments. But if we, for example, let's look at the Havoc application. So if I go over here, I basically have these additional fields, right? So these are extra command line arguments that my algorithm needs. So for example, there's kvals. So in a scenario like that, I would just add another command line argument like that, and then my algorithm can now use this kvals command line argument inside of the code. Um, yes. So right now we're just going over. So we'll go over both of them, but um, yeah. But for your point, these will be both for CODIDO and local testing. So that means that, yeah, so for everything here, you basically leave it as is. Um, yeah, you can leave it as is. I just kind of want to go over what each line does with you guys. And then, yeah, and then once you get to here, uh, specified in the guide too, but below these lines, this is where all your code logic goes. So at this point, you don't need to worry about any of this. You just need to know that you can access your input file using the input file path, and you can save stuff to the output folder path. But yeah, we can go over this a bit more. But yeah, going back to this, let's see. So yeah, now we have the CODIDO if else statement. So right now we are just doing local testing, and that's why we specified in the Docker file to say CODIDO equals false, because inside of this algorithm or inside of the app.py file, we want to know whether we're running this on CODIDO or running this on locally. And when we're running this locally, we're basically just gonna grab the single file to work with, the single file being this cat.jpg file. So at this point, we can just go straight into your algorithm logic. So our single file now is accessible through the input file path variable, and we can save stuff to the output folder path, a variable. And this is also specified in the how-to guide. But the logic here is basically just it's just kind of loading this machine learning model, pre-trained model, and then it's going to run it through the model and make a prediction. So after we make a prediction, we want to save this output. So first up in line 53, we are saving this the output from our machine learning model to the output folder path. And I'm just saving this output as out.txt. So naming can be anything though. And if you need to save more outputs, that's no problem too, as long as you save everything to this output folder path. So at this point, this output that got saved in the Docker container can now be viewable in the output folders in your local machine. And the rest of the lines here are just for CODIDO purposes. We'll get back to that and some other things in a bit, but for now, let's first try running this and see how this works. So first thing we want to do is we want to package everything and create a resulting Docker image. So we do this with the docker build command. So here I have this already, but here I write the docker build and then a name for the Docker image, which we refer to as a tag. So the name or the tag that I have for this one, I call it just January 18 demo. And since I already ran this previously, to save time, basically no new changes were found and it finishes running right away. So now we can use docker run to run the Docker image. Let's see. However, files that get saved in your Docker container are not automatically accessible from your local machine since, as you mentioned previously, it's running in its own enclosed space. And by default, they don't share the kind of file system stuff. So even though I'm saving my output into out.txt, it's not going to be visible here. And so for that case, we have to modify this command a little bit. But first, let's just see what happens when we run it like this. So when I run it just as is, so it was able to load the image, it was able to make the predictions. Here I think I had a print statement here. Yeah, I had a print statement here. That's why it's kind of printing it out into the output. But then when I save it, we can see that in our local project directory, there's nothing in the outputs folder. And so, yeah, so this is going back to how the Docker container is running its own enclosed space. So to address this, we use the concept of volumes so that the output folder in our Docker container, which we know as /app /outputs. So this one right here, we want to map this folder /app /outputs, and we want to map that to the outputs folder in our local computer so that, stuff that's saved in our Docker container, we can now view it in our local directory. So to do this, the modified Docker command looks like this. So it includes this -v, and then I specify the local outputs folder. So this is just the absolute path to this folder. And then this is the Docker container outputs folder. So this is also specified in the guide. But let's try running this command with the volumes parameter. So after this finishes running, I can now see that in the outputs folder, we have out.txt. So we were able to successfully map the output folder in our Docker container to the output folder in our working directory. So now we can see how that works. So this provides a streamlined way for local development where you can just put your inputs in this inputs folder and then you can view your outputs in your local directory with little modification to the provided code on the CODIDO guide. So the structure of how this app.py file should be and the kind of boilerplate code is provided. So now I just want to quickly go over what happens when we want to publish our algorithm onto CODIDO. So first thing, let's just go over the app.py from the perspective of it being run on CODIDO. So this time the code will use input and output. And so when the user uploads an input on the site, we will have the path of their input on our cloud storage, which gets passed in here. And output is similarly for when where we will upload the results so that the user can view the results in their dashboard. And the args.codido will be set to true. And these lines are just for downloading the user's input file that's on the cloud to the file specified by input folder path. So now for the rest of the code, we can now access their file locally through this input file path variable. So you can see that how for both local testing and for CODIDO, we access the file to work with through this input file path variable. So in that case, you don't really have to worry about these, even if it's a little bit confusing. You just need to know that in your algorithm logic itself, the file that you want to work with is accessible through this input file path. So you can read it, you can do whatever you want with it when you are writing your algorithm. So I'm just going to scroll down to saving the outputs. So when toasting locally, we were able to save the bunch of files, and this all ended up being accessible locally through the outputs folder. But for CODIDO, we want to zip this all up. So that's what this part is doing. It's just creating a tar.gc file, which is basically a zip file. And this is basically going to contain all the outputs that you have in this outputs folder. And then we finally just upload it to our cloud storage with this very last line. So as we can see, there's basically no code changes that you need to make when going from local testing to CODIDO publishing. And going back to the Docker file, so even here, there's very little modifications that you need to do. But the first thing that you want to do is that if your computer is not Linux AMD 64 and you are testing locally, um, yeah, so if you were developing on your own computer and it wasn't Linux AMD 64, then you just want to make sure to rebuild your Docker image with this flag so that it makes it all compatible with the CODIDO machines. And the second thing is that when we're testing locally, we want to use these inputs and outputs folders, so that's why we're copying them over. But we don't want these to be copied over to the container that's being run on CODIDO, because we don't want to have this demo image here plus the user's file that they uploaded. So what you can do for that is we'll have this extra file called the docker ignore, and this just specifies what we don't want to be copied over to our Docker container. So in testing locally, we want the inputs and outputs to be copied over, but when on CODIDO, we don't want these to be copied over since we're going to be using the user's input rather than these demo images. So you could just put something like inputs, outputs, so that it kind of ignores these. And yeah, maybe if you have some other large files that are not necessary, like virtual environments and stuff like that, then you want to ignore those as well. So this is also specified in the CODIDO guide that's online. So after you make these required changes and you build your Docker image, then you can pretty much just publish this to CODIDO. So I'll just quickly go over some of the stuff here. So this button is just for the guide. It'll contain a lot of the information that I was saying today. And then we have the authentication portion of it. So this is a command that you can pretty much just copy and paste straight to your command line. And this is just for right before you publish your algorithm to CODIDO. This is just that intermediate step that authenticates you. And then you have the create for creating the actual repo. So you can create the repo, refresh the page, and then you basically will have one of these cards pop up on your dashboard. You can change the name, change the description, whatever you want to do. So if we just open up the quick commands, so we can see that here, when we were testing locally, we already were building the Docker image, and then assuming that you made some changes to make it compatible with CODIDO, after you finish building that, you just need to run the commands in the second step. So these are pretty much also just copy and paste, except you want to swap out the name for the name of your Docker image. So in this case, it was January 18 demo. And the version, you can just set it to 1.0 if it's your first time. And also keep in mind that anyone with this repo name, these repo names, anybody can push to your repo, so you wouldn't share this in public. And then before you can actually call this line, this push command, you basically need to authenticate yourself. And so that's going back to this part where you just copy and paste this. And then once you do that, you'll be able to run this command. And then, yeah, so once you run these commands, then your algorithm will basically be populated, and your algorithm will be runnable on CODIDO. And so we have 3 extra minutes for the Zoom call. I'll just quickly go over the extra command line arguments thing. So let's say you need extra user-defined parameters. So I'll go back to this Havoc one, or actually I'll do the ImageNet classification one. So as I mentioned, there was no extra command line arguments that I needed. But let's say that, I want this extra user-defined parameter called like x, and let's say the default value is like 5 or something. Then that means that now when a user tries to run it, when a user tries to run this image classification app now, there's now going to be this extra field called x. And then, as mentioned before, you would have an extra command line argument called like x or something. And then, inside of your code, you can do stuff with that args.x and do whatever you need to it. So that's just how you add extra parameters on the CODIDO site to make it compatible with whatever you have here. And if you do have that extra command line argument here, like x, then when you're testing locally, you would also just put, something like, something like this, for example. I think I have to use double quotes, but yeah, if you want to use extra command line arguments, you would just modify your code slightly like that. That's also present in the CODIDO guide. So I think this Zoom call is going to kick us off after 1 minute. Do you guys have any questions? Okay, sure. Yeah, I think if you, after I went through this, if you go through the how-to guide a bit and just try to create a simple application, like for example, I have, I have some machine learning logic in here, but even if you just swap it out with a hello world thing and just copy and paste the code that's present on the guide, then I think that'll kind of solidify your understanding of the flow a little bit better. But yeah, I recommend kind of just going over the guide and seeing if you have any more questions. Yep. Okay. If that's all, you guys can always email me if you guys have any questions. Okay. Yep. Thanks, guys. You too. Bye.